number 7. Alright, so question number 7 reads, what is the remainder when 3x to the power of 4 plus 2x cubed minus x squared plus 2x minus 9 is divided by x plus 2? Okay, so we're going to use two different methods here. We're going to use long division and synthetic division. So I'm going to go through long division first. And the junior tutor also used a different method, and I'll also cover that method too, okay? Alright, so let's use long division first, okay? So long division requires us, so I'm just going to, so long division requires us to have a big long bracket here. Alright, and I'm going to have our divisor of x plus 2 on this other side. Okay, so long division is similar to division, and you're going to treat each of the terms of a polynomial as a digit of your number in normal division. Okay, and these are going to be also treated as digits. So all the terms in your divisor and in your dividend is going to be your digits. Okay, so just like in normal division, you want to reduce this big number or this big polynomial within the bracket to the smallest size, to the smallest as possible, right? So instead of multiplying your digits by numbers, by other digits, to subtract from this large number, we're going to multiply our divisor by values of x, or variables of x. Okay, so to get rid of 3x to the power of 4, right? So we have to multiply our divisor by x cubed, right? And not only x cubed, we want to also get rid of this 3. So we're going to multiply by 3x cubed, okay? If we multiply by 3x cubed, we get 3x to the power of 4, right? 3x cubed times x plus 2 is 3x to the power of 4 plus 6x cubed. And if we were to subtract this, we would get negative 4x cubed. Okay, now we're going to move down our next digit. Alright, so how do we get rid of negative 4x cubed? We could multiply our divisor by 4x squared. Okay, so we multiply by 4x squared, we get negative 4x cubed minus 8x squared. And if we subtract all this together, this is equal to 0, and we get 7x squared. Move down our next digit, so it's plus 2x. How do we get rid of this? We multiply by 7x, and we get 7x squared plus 14x, and we get negative 12x minus 9. Okay. Okay. So now we want to get rid of this, so we just multiply it by a number. We multiply by negative 12, and we get plus 24, or minus 24, sorry. If we subtract this, we get 15. So our remainder, which we were actually looking for in fact, is 15. Okay, so this is long division. We're also going to use synthetic division to also solve this too. Alright, so synthetic division. Okay, so in the same way that we took a bracket, we're going to also make a bracket, but this time we're going to take a inverted division bracket. So we're going to flip it upside down, and we're going to make it pretty large. This time we're not going to write down our polynomial. We're going to take the coefficients of our polynomial. So we're going to have 3, 2, negative 1, 2, and negative 9. Okay, and this corresponds to x to the power 4, x to the power 3, x squared, x constant. Okay, and instead of taking our divisor as it is, we're going to take the 0 from this divisor. So the 0 from this proposed factor is negative 2. Okay. Alright, so what we're going to do now is we're going to move this. So we're going to do this kind of division. It's not really division. It's more of like finding the coefficients for your quotients. Okay. So we're going to move our first term down, So we're going to move it down here as 3. We're going to multiply our divisor or our 0 to the term and add it to the next term. Okay? So if we were to move our term down, it times it by -2 is -6 and add it to 2, we would get 4. Alright, and now we're going to do -2 times 4, -8. Add it to -1. Hold up, sorry. -6, -4. Alright, so -4 would be 8. Add it to -1, which would be 7. -2 times 7, -14. Plus 2, which is 12. Wait. Yeah, 12. -14, -12. And finally, we're going to take -2 times -12 and add it to -9. So that'll be 24 minus 9. That will equal to 15. Okay, so as I said, this corresponds to x to the power of 4. The quotient is going to correspond to a degree lower than that. So it's going to be x cubed, x squared, x coefficient. And this last number is going to be our remainder. So this is our remainder here. This is coefficient, x squared, x cubed. Okay, so our remainder here is also going to be 15. Cool. Finally, the third method is what the junior tutor did. They've foregone all the division and they wanted to just test out what the remainder is. And this is a totally valid method. Okay, so this method, I don't really know what it's called, but we'll call it the substitution method, okay? So in the substitution method, they're going to take the 0 of the divisor and they're just going to sub it into the polynomial because they know there's going to be a remainder. So this whole talk about long division or synthetic division, it's to test whether or not your proposed factor is indeed a factor. And the test is that if you have a remainder of 0, then this is indeed a factor, and this is indeed a solution to when this polynomial is equated to 0. Okay, so in this case here, we know that there is a remainder. So what the junior tutor suggested is that we just plug in the 0 here, we plug it into the equation, and whatever value we get from that equation is going to be our remainder. Okay? So the 0 from our divisor is going to be x equals -2. So we're going to sub x equals -2 into our function here. Okay, so f of x is equal to 3x to the power of 4 plus 2x cubed minus x squared plus 2x minus 9. Okay, so we're going to plug in f of -2 in here, and we're going to get 3 -2 to the power of 4 plus 2 times -2 to the power of 3 minus -2 to the power of 2 plus 2 to the power of times -2 minus 9. And we get 48 minus 16 minus 4 minus 4 minus 9, and that gives us 15. So that's our remainder. So we can see through all three of our methods, we got the same remainder, so this is obviously correct. And they wrote the remainder as the remainder over the divisor. So this solution is correct. Good job. Alright, let's move on to question number 8. Sorry, just give me a minute. I'm just going to